teachers and students. One of the things that I like about science is that it's all around us. You might think you need a laboratory to do science experiments, but you don't. There are many things in your home that you can use to just do science on your own. And to show you, today we're going to do some experiments that just use water and some other simple materials that you can find in your home. Teachers, you may want to follow along and do these experiments with your students. To begin with, I have 5 glasses here and I put a little bit of food coloring in each one. Now I'm going to add some water to them. And you'll notice that I varied the amount of water in each one. What experiment could I do with this? We could play songs. Could you play something like Mary Had a Little Lamb on glasses? I'm afraid I don't have very much musical talent, but that's one thing that we could do with glasses. What's causing the different notes that we're hearing from these? And exactly how much water would I want to put in them to create the notes that I might find on a piano or a guitar, another musical instrument? Well, it turns out that the amount of water affects the vibration rate of the glass. It seems like with a little water, we get a higher note, but with a lot of water, we get those lower notes. Higher notes have what's called a higher frequency. There's more vibrations per second. And lower notes have lower frequency. There's less vibrations per second. There's a whole branch of science called wave technology that studies how waves of sound and waves of light and even waves of water behave. So experiment with some different cups and see if you can find a way to play a song using water. And if you need to change a note because it's a little too low, it's not hard to change it. Here's another interesting experiment that you can do with water. You'll need a little bit of water in a glass. I've added some food coloring so that you can see this one better. And I would do this experiment over a sink or a tray because it can get messy. You'll also need a piece of fairly stiff cardboard or plastic. And I'm simply going to set that on top and then turn it upside down and let go. And that stays in there. For some reason, the water doesn't fall out. But why not? What's keeping the water in that? Well, in order for the water to fall out, this air would have to expand. And the air can't expand. It can't get bigger because of air pressure. And no air can get in because of that piece of cardboard. So even though that cardboard isn't that strong, it's sealed on the water and air cannot get in to push the water out. This is called air pressure. And we have air pressure all around us. I know you can't feel it because the pressure outside of your body from the air is same as the pressure inside your body. In fact, there's 14 pounds of air pressing down on every square inch of your surface, of your skin. But you can't feel it because the pressure inside is equal, just like we see here. The air pressure outside and the air pressure in that jar are the same. In order for that water to go out, I would need the air pressure in that to change, and it can't change. So try that one yourself, but make sure you're over a sink because as you can see, it is dripping. And if I break the seal a little tiny bit, out goes the water because the air can then get back in. Here I have a salt shaker with some red food coloring in it and some very hot water. Here's another salt shaker with some blue food coloring and ice water. Let's pour the hot water into this one, so you'll be able to tell them apart by their colors. And the ice water into the blue. Now I'm going to put the cold water on top of the hot. And there they go mixing. The hot water, the hot red water is rising, the cold blue water is falling. And now they are both purple. So here's our ice water and our blue food coloring, our hot water and our red food coloring. I'll fill the blue one all the way to the top. And I'll fill the red one most of the way to the top. Leaving a little bit of air helps the paper stick onto it when I turn it upside down. Notice when the hot water's on top, it stays on top. And the cold blue water's on the bottom, it stays on the bottom. You can see some bubbles rising because I don't have a completely airtight seal there. But the cold water likes to stay low and the hot water likes to rise to the top. A long time ago, I was talking to my 8th grade students about water during a chemistry lesson. And of course, they knew it as H2O, meaning that it has 2 hydrogen and 1 oxygen atom, making up that molecule. And therefore, I told them that its technical term was dihydrogen monoxide, meaning 2 hydrogens and 1 oxygen. Well, one of my students took a clipboard and a pencil around his neighborhood that evening and told his neighbors that they'd found dihydrogen monoxide in the city's water supply and wanted to know how they felt about that. And reported the next day that all of his neighbors were opposed to having dihydrogen monoxide added to their water. So I hope you've enjoyed these experiments with water, or as we like to call it in chemistry, dihydrogen monoxide.